Okay, we're going to talk about redox in this section. We're going to begin by explaining what it is. And lots of times, if you have seen these old rusty cars, if you've ever lived in snow country, it's because we're having redox happen. And so they have to add a lot of things to the underside of cars and in the paint so that this will not happen. So we're going to talk about redox chemistry. So we're going to talk about adding or subtracting oxygen, or we're going to talk about adding or subtracting electrons in redox. So if something gains oxygen in a chemical process, it becomes oxidized. If it loses oxygen in the process, the chemical reaction, then it's reduced. And so these are called oxidation reduction, but we call them redox for short, so we don't have to say all that so long. Chemists like to do everything in shorthand. So here's a Bunsen burner. It's oxidizing the methane fuel that's coming in here. And it's allowing oxygen to react with the methane, and we're forming carbon dioxide and water. So this is a redox reaction. So we have methane in the burner, we have oxygen coming in through the air, and we're forming CO2 with that. And we're also forming water. Remember, anytime we have a combustion reaction, we have a fuel, oxygen, we're forming CO2 and water. That's something we have to know. So carbon's oxidized when charcoal burns in air. We have carbon, we have oxygen in the air, and we form CO2. Another oxidation, another combustion reaction. Iron can oxidize in air because it'll turn into rust. We have the iron, new iron, oxygen attacks it in the air, and we form rust, which is this formula right there. So how's gain or a loss of electrons linked to this as well? So losing electrons is oxidation, and gaining electrons is reduction. So oxidation is defined to mean complete or partial loss of electrons or the gain of oxygen. A reduction is complete or partial gain of electrons or loss of oxygen. So those are good definitions to know. Here we have, we can have magnesium and sulfur together. We can heat it up and it will turn into magnesium sulfate. We want to know, hey, is there a redox reaction going on here? And there is. Magnesium has 2 electrons. Sulfur would like to have 2 to balance this out for an octet. When this happens, magnesium becomes magnesium ion, and sulfur becomes sulfide ion because it grabbed those 2 electrons. So magnesium lost 2 electrons, so when you lose, it's called oxidation. Sulfur gained electrons, it became more negative, so it's called reduction, and it gained electrons. So this is like a basic thing you should know for redox. I'm not so concerned if you know what a reducing agent is. It makes something get reduced. An oxidizing agent makes something become oxidized. But I'm not going to ask these questions because I just need to know who's oxidized and who's reduced in a chemical reaction. So how would you figure it out? This right here is silver nitrate, copper metal, turns into copper nitrate, and silver metal. So if there's no charge on something, it has a charge of 0. So this guy right here has a charge of 0. This guy right here has a charge of 0. So let's see what happened. So that's why you need to know your polyatomics, because nitrate, remember, is -1. So if there's one -1 chunk here, this is going to be a +1 charge. If there's 2 negative chunks here, then this copper is going to be a +2 charge when we're done. Okay? So we have to figure out who's losing, who's gaining. So let's just look at the copper. It became a +2 when we were done. It lost electrons, so it's oxidized. Silver was a +1 at the beginning. It gained 2 electrons, so it became reduced. And I don't care so much if you know this part down here, but I need you to know this from there up. Try those ones yourself. See if you can figure out who's oxidized, who's reduced. And I don't care if you know about the oxidizing agent, reducing agent. Just know who is oxidized, who's reduced. And we can have covalent redox as well. So let's look at this. This guy all by himself has a charge of 0, but afterwards this becomes -2, and that each H becomes a +1. So this is actually redox going on, even in covalent compounds. So here's some rules to remember. This chart will probably help you, so I would make sure you know these. And let's look at corrosion. We were showing that on the card at the very beginning. So iron is really easily oxidized. So this is what's happening with the iron. It's reacting with water and oxygen and doing a redox reaction. So if aluminum is more resistant to oxidation. So it forms its own little aluminum oxide coating, and so it has this beautiful coating on the top when water and oxygen hits it, and then it keeps aluminum from getting more corroded and messed up. So we paint surfaces to protect corrosion. We add protective coatings. We add metals on top of metals, and to keep things from corroding. In big ships, they'll put a zinc block on the bottom of a ship, so it will allow the zinc to oxidize and not the iron. So let's see what you got out of this section. So choose the right words and pause me if you need to, and let's see if you can figure this out. Okay, so the answer is that. Next question. So during reduction, what's happening? So there you go for that one. The element that donates electrons, this one I'm not so concerned about, so I'm just going to move on to that one. I don't really care there, but this one you probably need to pause me and then figure out who is becoming oxidized, and that would be a reducing agent. And last but not least, what substances are being oxidized? So this is a really good question. So take your time on this one, pause me, and then I'll give you the answer when we start me back up. All right, there you go. So I hope you learned a little bit about redox. It's important. We use it a lot in chemistry, and you need to recognize who's being reduced, and who's being oxidized. All right, I'll talk to you soon. Bye-bye.